Here we have to evaluate the line integral either directly or using Green's theorem. So let's start out with we're gonna first draw our coordinate. We have 0, 0, 1, 2, 3, 3, 1, and 0, 1, and 3, 1. It's a rectangle. Okay, and then for B later, I'm gonna have a positive orientation. So it's gonna be counterclockwise. It's gonna go this way. Part of a Green theorem. So I'm gonna have a C1 here, C2 here, C3, C4. The C here stands for curve. I know we have a line, but just bear with me. Think this as a curve for now. Okay, and we have a region bounded here. Okay, we have to write the parametric equation. So I'm gonna break it to 4 different equations: C1, C2, C3, and C4. And each of these numbers correspond to C1, C2, C3, and C4 curve right there. And we have to set the time. I'm sorry, not time, but well, it's a parametric equation. A lot of times the t will be time, but it's not necessarily time. So I'll say t for now. So t, I'm gonna make it 0 and 3 because it makes our life much easier. You can choose different numbers if you want, but make sure they're consistent with the parametric setup. So we have a t between 0 and 1 because we have a 1 unit difference. And for our C3, I'm gonna have t's between 0 and 3 because another 3 unit. And for our fourth, I'm gonna say 0 and t1 because there's only 1 unit difference. Okay, now that we set up our t, we have to set up the parametric equation for both x and y. So for x, for the curve 1, I'm gonna have t because I have t between 0 and 3. As you see up here, when t equals 3, x has to be 3, right? So when t equals 2, x has to be 2. So we have this nice relationship. And for y, it's simply 0. Y equals 0. Okay. Now moving to the second curve, I'm gonna have 3 because we have x equals 3, and then y here will be simply t because from 0 to 1 we move up 1, right? So imagine we are like a 0.5 t equals 0.5, then we expect the y to be 0.5 as well. So in the same fashion, I'm gonna complete the parametric equation like this. Okay, I'm just gonna clarify one here. When you're up here, you have to go down to 0, right? So as t progresses to 1, we expect our final point to be 0, 0, and this is good. I'm also gonna have a dx and dy, dx over dt and dy over dt, because when we evaluate the line integral, you have to have those in our arc length formula part. So dx equals, obviously when you take when you take derivative with respect to t, it's just simply dt, and then dx becomes 0 dt, and then dx for our third curve becomes negative dt, and finally 0 is 0. Okay, and for our dy's for each curve, we have 0 dt and dt, 0 dt, and negative dt. In case you don't know what I'm talking about, you need to review calculus 1 how to take derivative. Alright, assuming you all know that, moving to next part, we're gonna evaluate this in this form. C1, C2, C3, and C4. We're gonna combine over the line integral part, and we have to have such equation. This is a given, and to solve this, seeing that, I'm just gonna make it 4 different parts. So starting out with our C1, we set the lower limit and the upper limit to be between 0 and 3. So just copy that down, and then x is what? X equals t, and y is 0. So everything here in this term will go to 0. But I'm just gonna complete it for you. So when you look for the dx, it just becomes dt plus, and then x squared, t squared, but then our dy is 0, so everything just cancels out, for our C1. Now let's go to C2. It's between 0 and 1, and again our x is 3, y is t. Make sure you look at our second row, and our dx is 0 dt. It cancels out, and then x squared is 9, and times dy is dt. So it's not completely gone, only this part is gone. Going to our C3, it's between 0 and 3, x times y, so it's just 3 minus t. I'm not gonna multiply 1 here, it's too messy. And dx is negative dt, and x squared is this, but fortunately we have a 0 dt, so we won't have crazy integral. Our fourth integral, it goes from 0 to 1, and well, it's gonna be over 0, right? So the first part is over 0, second part x squared is also 0. So fourth part I'm not really gonna write down, but you just get the idea that everything here will cancel out. So I'm gonna cross out anything that's not needed here. Gone. This side is gone. So that whole thing is gone, and this is gone. So there only leaves 2 integral that we can evaluate. So for the constant, I can move it toward in front of the integral sign, and I have that, plus I have, I can put negative in front because of negative dt. So put the minus sign, 3 minus t and dt. Let's evaluate this. It's very simple. When you have nothing, there's implied 1 here, 1 times dt. So it simply becomes t, and don't forget 9 in front, and it's evaluated between 0 and 1. And then for this, we'll have 3t, and then t squared over 2. Make sure you evaluate it between 3 and 0. Alright, so the first part just simply becomes 9. The second part, you get 9 minus 9 over 2. 9's cancel out. Make sure you put the plus sign because of this minus times minus become positive. So you get 9 over 2. That's our final answer for the part A. So we're not done. So what this problem is designed, how this problem is designed is to make sure that you get the same answer for both A and B. If you get wrong answer, you should always go back and change and correct it. So now we're gonna use, so this was a lot of work. Let's use a Green Theorem to make this process much simpler. So moving on, I'm gonna first define the Green Theorem. It's green, so I'm gonna use the green color. Okay. Okay, this is the okay, this is a question. Okay, I'm gonna restate the question. Okay, I'm gonna also specify this is our pxy, and that's gonna be our qxy. I mean, it's good to separate this so that you won't have much trouble later, or it can be very confusing if you don't really separate it like that, because you want to deal with a lot of partial derivatives and so on. So the formula actually goes, when you have a pxy dx and then qxy dy, you're supposed to have this, you are supposed to use this formula. Okay, remember that this funny looking d is a partial derivative. It's not the regular derivative used in calculus 1 and 2. Okay, so using that formula, we have a domain which we drew already. We have to how should I say? We have to first separate these and take derivative. Take partial derivative. I'm sorry. Partial derivative. And it's just simply plug in, and that domain is going to be very simple, double integral, because we have a rectangle. So it doesn't matter if you switch dx and dy. Okay. So to solve this, let me draw all the parts. Let me write down all the parts. So p xy equals xy. 2 becomes the x squared. I'm also going to take a derivative. When you take a derivative with respect to y, reason is you see that p, our first equation, is derived with respect to y, so that's why I have a y here instead of x. When you take derivative, okay, x is like a constant. X is a even though it's a variable, we have to treat it as a constant, so it just simply becomes x. Okay. And for our q, we're gonna have this. Okay, this is x squared, by the way. So when you take derivative with respect to x, you get qx. Okay, you get x and qx. So we simply plug this in. This goes here, and that goes here. Qx minus x, you get x. Now for our domain, the region, we saw from our graph above. Okay, you see that our coordinate here. So for x it goes from 0 to 3, and for y it goes from 0 to 1. So we'll have, okay, let me do that again. So this was 0, 3 and 0, 1. I'm gonna have the y over dx, doesn't matter, you can always switch if you want. dy goes from 0 to 1. So remember that integral is always you approach it by nested form. So what's inside first and then outside. And for x goes from 0 to 3, you get x 1, 3, 0, dy dx. But you notice that in our inner integral, that x can be pulled out since this is treated as a constant in this dy form. So we can have 3, 0 x dx and then 1, 0 dy. Now let's evaluate separately. X becomes x squared over 2. Upper is 3, lower is 0 times. This will be simply y okay, so when you plug it in, you get 9 minus 0 times 1 minus 0. Well, just become, oh my god, okay, 9 over 2. Okay, 3 times 3, you get 9 over 2. Well, 0 squared over 2, I'm not going to rewrite that, so it just becomes 0, and so on. So simply you get 9 over 2. That's our final answer. And notice how this answer is same as our part A answer. So we have the correct answer. Alright, that's it guys. Thank you for watching.